What is up, Prealgebra? This is lesson 112. Objective for today is how do you find the ratios of side lengths of right triangles? Or really, this is also an introduction to trigonometry. Trigonometry is a branch of mathematics that compares angle measures, or right triangles with specific angle measures, and the ratio of side lengths. So remember, if you have a couple triangles that are similar, or we know a couple triangles are similar if all three angles are the same. Also remember that all three angles add up to 180 degrees. So if you have one angle that's 90 and another angle that's the same, that means this last angle would also have to be the same, which means that those triangles would be similar to each other. The red would be the same as the red, the green would be the same as the green, and the right angle is the same as the right angle. So these two triangles would be what we call similar to each other. If they're similar, that means the ratio of their side lengths are the same. For instance, maybe this one is 3, 4, 5, and this one is 6, 8, 10. If you compared ratios, let's say 3 over 5, this one over this one, would be the same as this one over this one, because it would be 6 over 10, which reduces down to 3 over 5. And that would be true for any set of ratios as long as you stay the same, as long as you follow the same pattern each time. Now, in order to work in trigonometry, we need a few vocabulary words, and one of them we already know, and that is the hypotenuse. That is the side length opposite the right angle. And then we have two legs, which we already knew about, but these legs we're going to give specific names so we know which one we're talking about. And that comes in respect to a specific angle. So for this one, let's talk about angle A. The side opposite that is a side opposite angle A. Notice this is angle A here, so it's across from it. It's not adjacent to it, it's opposite it. And then we also remember that adjacent means right next to, and that's what we call this slide here. And of course, we abbreviate those. Hypotenuse, we say HYP, opposite OPP, and then adjacent ADJ. So we could do the same thing, but if we're talking about angle B this time, down here, well, the hypotenuse would still be the same, because that's always across from the right angle. But the opposite of angle B is going to be over here. And adjacent is going to be next to it. So notice whenever you're talking about any specific angle, any acute angle on a right triangle, its two sides are the adjacent side and the hypotenuse. And the opposite is the one not touching that one. So now let's start finding some ratios of side lengths. So example 1 says find the ratio of the lengths of the side opposite of A, so here's A, the side is opposite that, to the length of the hypotenuse, that's this side up here. So for A, I would do that green side divided by the blue side. So this is 3 divided by 5. For B, it says find the length of the side opposite of X. Here's angle X. Here's the side opposite that, to the length of the side of the hypotenuse. Hypotenuse is across from the right angle over here. So then that is going to be 6 over 10, which of course we want to reduce down to 3/5. But then I'm kind of skipping over this. It says express the ratio as a fraction and as a decimal. So if we're going, there's the fraction, the decimal, 3 divided by 5 is 0.6. You can do that on a calculator or by long division, either way. And so this is going to be our answers for A and B. Last one, it says with respects to A, find the ratio of the length. So let's start with A here. This is with respect to A. here's A, so that's going to be for this section. Find the ratio of the lengths of the opposite to the adjacent. So remember, this over here is going to be opposite of A, and this side is going to be adjacent. So if I'm going to say opposite to adjacent, this is going to be 2 over 2 square roots of 2. The 2 will reduce down, giving me 1 over the square root of 2. And then if we multiply that by the square root of 2 over the square root of 2, which is just 1, that gives us the square root of 2 over 2. And that we've done in previous lessons, so should be somewhat familiar to see that. And then the last one is adjacent over the hypotenuse. So remember, up here is the hypotenuse. So the adjacent over the hypotenuse is going to give me 2 square roots of 3 over 4. Of course, those are reduced down. 2 goes into 2 one time and into 4 two times. So it's going to be the square root of 3 over 2. And then if we want to estimate these into a decimal, we'll just want to use our calculator. And if you look in your book, it says to round those to 3 decimal places. So this would be the answers for those, an approximate. Now when we're talking about this next one, now it says with respect to B. So now we're talking about this angle up here, not the blue, but now we're working with the green. So for the green, this side is no longer opposite, this is the adjacent. And this side over here is the opposite. And this is still the hypotenuse for both of them. So now if we want to do the opposite over the opposite over the adjacent is going to be that 2 square roots of 3 over 2. Which those reduce down, so it just gives me the square root of 3, which is about 1.732. And then for part B, it says the adjacent to the hypotenuse. The adjacent to the hypotenuse is going to give me 2 over 4. That reduces down to 1/2, which is equal to 0.5. Alright, your homework is down here, page 739. You can do the practice set. You can do all the 112s, all the 111s, and 6 more of your choice.